Hello, check out this challenge here. The question is t to the power of 3 equal to the square root of 2. What is the value of t here? Here we are asked to look for only the real solution, okay? So here we're looking for the real solution. So how do we get the real solution to this? Let's take our challenge here now. So take our solution rather. So let's take our solution, please. Okay, so here we have our t to the power of 3. Move this quantity this way to give us minus the square root of 2 is equal to 0. With this power we have here, there's no way we can rewrite our t to the power of 3 to give us difference of 2 square. Okay, in other words, to raise this to the power of 2 without t still playing out of the system. So what we do here is to rewrite this to enable us achieve difference of 3 cube. So this could be written as our t to the power of 3, then minus the square root of 2 all raised to the power of 3 all over 3 equal to 0. We're going to apply a law of indices which says that if you have your, let's take you have your x all raised to the power of your, let's take our m all over n. This is same thing as our x to the power of m all raised to the power of 1 all over n. And we can equally express this as our x all raised to the power of 1 all over n all raised to the power of m. Okay, so we want to rewrite this to make sure we have 3 at the power here. So this could be written as our t to the power of 3 minus the square root of 2 all raised to the power of 1 all over 3, then all raised to the power of 3, this is equal to 0. So here we have what we call difference of 2 cube. So what does it say? It says that when you have your x to the power of 3 minus y to the power of 3, this is equal to your bracket x minus y close bracket your x squared plus your xy plus your y squared. This is what we call difference of 2 cubes, right? So with this difference of 2 cubes, then we can rewrite this expression. So this expression could be written, or this now implies that our bracket open, our t, then minus the square root of 2 all raised to the power of 1 all over 3. Okay, then let's close this with a square bracket, then square bracket open again. We're going to have our t to the power of 2, then plus our square root of 2 raised to the power of 1 all over 3 times our t, then plus our square root of 2 all raised to the power of 1 all over 3 all raised to our 2 equal to 0. Okay, so with this, we have 2 case scenarios here. Okay, we equate this to 0, we equally equate this to 0. So that way we can say here case 1. So we have our case 1. We're going to have our t, then minus the square root of 2 raised to the power of 1 all over 3 equal to 0. So let's continue on this side. Okay, move this to this side of the equation. So we're going to have our t will now be equal to the square root of 2 further raised to 1 all over 3. And if we apply this rule, okay, this could be written as our 2 to the power of 1 all over 2 times 1 all over 3, which is equal to 2 to the power of 1 all over 6. So we have our t1 is equal to 2 to the power of 1 all over 6. We've gotten the first value, which is a real solution to this challenge. Now let's take the second part of it, which is our case 2. Our case 2. What is our case 2? Our case 2 is going to give us our t to the power of 2. Then we have here plus our 2 to the power of 1 all over 6. If we open up this, okay, t, then plus Yeah, if we also open up this is going to give us 2 to the power of 1 all over 6 times 2, which is automatically 2 to the power of 1 all over 3, right? So we have here 2 to the power of 1 all over 3 equal to 0. Now, this is a quadratic equation, right? Good. But let's check if we are going to get a real solution from here. How do we check that? Let's use our determinant is equals to b squared minus 4ac, right? So let's substitute. What is our b here? Our b is 2 to the power of 1 all over 6. So we have here 2 to the power of 1 all over 6 all raised to power 2, then minus 4 times our a is 1 times our c is 2 to the power of 1 all over 3. Okay, so this is equal to, this is going to give us 2 to the power of 1 all over 3. This 3, please. Then minus, this could be expressed as all the same. Let's just go on. So we're going to have here 4, then times our 2 to the power of 1 all over 3, because 1 times 4 will still give us that. So if we decide to factor 2 to the power of 3 out, this is going to give us our 2 to the power of 1 all over 3, bracket 1, minus 4. So this is going to give us 2 to the power of 1 all over 3, the bracket minus 3. So this shows that we are going to have imaginary root from this case 2. And so this is rejected. We are only asked to look for the real solution to this. Now, we can check if this actually satisfies the original equation. Simple. So let's take a simple check to this. So we have here check. The equation is t to the power of 3, then equal to the square root of 2. What is our t here? T is 2 to the power of 1 all over 6. So this is going to give us our 2 to the power of 1 all over 6, all raised to the power of 3. This is equals to root 2. So if we apply this rule here, then we're going to have here 2 here, 1, 3 here, 1 rather, 3 here we have 2. So we're going to have here 2 to the power of 1 all over 2 is equals to root 2. And this is same thing as root 2 is equals to root 2. So this is for fun, by the way. It shows that the answer t equal to 2 to the power of 1 all over 6 satisfies the original equation and is the only real root to this challenge. Thank you for being there. See you in our next class.